Hello and welcome to today's IBM webinar on enabling deep learning, AI, and machine learning. I'm Michael Downs. I'm the Chief Technology Officer for Evolving Solutions. And today I am joined by Elpida Tzortzatos, who is an IBM Fellow. She's been working as an IBM Z architect on the IBM Z OS core design. Through her 3 decades at IBM, Elpida has excelled in innovation, adding speed, security, and scalability to a wide range of computing technologies. Her achievements have focused on bringing new workloads and technology to the platform, contributing to innovative products and enhancements that have delivered significant value in a wide range of areas. Before I turn it over to Elpida today, I want to share with you a little bit about who Evolving Solutions is. Evolving Solutions is a technology solution provider, and we focus on modernizing and automating our clients' business-critical, mission-critical applications and technology. And we do that through what we call modern operations. Modern operations is the idea that our clients have come to us and said, we're really struggling to be able to continue to deliver the resilience, the availability, the security, and the performance that we have in our data centers as we move into this hybrid cloud world. And so we really look at 4 areas where we help our clients with that: data access and connectivity, pipelines and automation, observability, and data protection. And really all of this is about taking that capability that IT operations teams have, that ability to make sure that the business is successful with their technology, and adopting the processes, the technology, and the skills necessary to be able to do it in a new world. And that new world oftentimes includes things like making sure that our environments are developer friendly, that developers are able to use the technologies easily so that they're adopting technologies that have always been there. And with IBM Z, we're seeing this rise in support for artificial intelligence and machine learning, and that's a key component of many of the applications and tools that our clients are building today. So with that, I will turn it over to Elpida and let her get into today's content. Elpida?
Thank you, everybody, and it's a pleasure to be here with you today to talk about a subject I'm very passionate about, AI on Z systems. I spent the better half of the last 4 years working on AI on Z, both working with my hardware colleagues, but also on the software side to ensure that we put not only hardware acceleration on our Z servers, but we deliver on the ecosystem support that allows you to very easily and quickly embed AI intelligence into your workloads. And we all know that AI is the most important transformative technology of our time, and that it is creating new capabilities and offers multiple benefits for enterprises and businesses alike. And really, I wanted to hit on a couple points from a couple studies that were done here in terms of the benefits and importance of AI across many different businesses. And you can see here from a study from Forrester that businesses that deploy the right AI can make faster, more informed business decisions and increase the productivity and operational and efficiencies, as well as improve their client experience and customer satisfaction. And businesses that fail to take advantage of AI are likely to be left behind. And the study conducted by Forrester found that really organizations that are advanced AI adopters can scale their AI, and they're 7 times more likely to outperform their competitors. And also, you see findings on these charts from studies conducted by McKinsey and Deloitte that really speak to the impact and importance of AI across many different industries. And as you can see here, AI already has an impact in a variety of different industries, from finance to insurance to governments. And the importance of the AI, it's only going to continue to grow in the future. From a Z perspective, we really anchored our AI strategy around 2 key pillars. And the first pillar was all about really enabling you to very easily and quickly consume AI and apply AI to your data, your applications, and core business processes. And we provided a lot of the AI ecosystem in terms of IBM AI offerings, but also we coupled that would bring into Z a lot of the popular AI frameworks and tooling from open source, as you can see here on the bottom of the chart. And then a second really key pillar of our AI strategy is leveraging AI throughout our Z stack and across many of our own products offerings. And you can see here that we're leveraging AI in the AI apps space with CloudPak for Watson AI apps, but also with IBM Z Anomaly Analytics for ZOS to help you enhance the resiliency of your IT systems, reduce mean time to recovery, as well as help you with faster problem resolution times. We're also leveraging AI in DB2 AI for ZOS to help you tune your DB2 applications for better performance. And then in the areas of data privacy and cyber resiliency, we already have tooling on ZOS that detect sensitive and PII data and redact that data from diagnostic memory dumps such as SVC dumps and standalone dumps before you send those dumps into IBM or other third-party vendors for diagnostics. And you'll see us to continue to invest in AI and leveraging AI to provide client value right out of the box, and specifically in the areas of cyber resiliency and security to help you protect your system from cyber threats and mitigate those cyber threats. And then what you see at the bottom on this chart is that both across those pillars, we've built a very strong foundation of an AI ecosystem that enables you to very easily leverage AI on your IBM Z servers and on your Linux One service as well. So not only have we provided our own IBM product offerings and brought the best of IBM's AI portfolio to Z and Linux One, and you can see here products such as CloudPak for data for our Linux environments, but also Watson Machine Learning for ZOS on the ZOS side. And we coupled that, right, with bringing the most popular AI frameworks and tooling from the open source ecosystem so that you can leverage these to really benefit from all that our platform has to offer. Now, just to give you a little bit of a background in terms of what really influenced our AI investments in general, both on the hardware side and on the software side, were discussions that we had with clients such as yourselves, also surveys that we conducted, and then papers that we looked at from other research that was done in the industry in general. Now, 80% of clients told us that being able to achieve real-time insights was important in achieving their business objectives. But yet, almost half of you told us that you were facing big challenges in terms of being able to operationalize AI and leverage AI in your mission-critical workloads. And two of the common challenges that clients have told us that they faced when it came time to really deploy AI models was one, the ability to be able to integrate AI into their existing systems without having to heavily re-architect those systems, and also or refactor your applications, and being able to apply AI to your transactions without slowing those transactions down. Being able to apply AI to, again, those transactions without, and getting the AI results and predictions back before those transactions complete. And then from studies conducted by Celent and research done by many others, we found that in the state of the industry with the AI infrastructure that clients had pre-Z16, most clients were only able to score 10% of their transactions in real time. So we wanted to build a system that addresses those challenges, that allows our clients to be able to score 100% of the transactions and apply AI to every transaction, every payment, and not slowing down those transactions and still meeting your SLAs and not impacting your SLAs. So what we've done to address those challenges, we've built an AI accelerator. This is an embedded on-chip accelerator that we delivered with Z16 that can actually serve up to 300 billion inference requests per day at 1 millisecond response time. And this really works out to about 3.5 million inference requests per second that we can serve at 1 millisecond latency. We wanted to make sure that we give you the speed and the scale that you needed to embed AI into your mission critical workloads without impacting your SLAs. But it was equally important to us that we provide an AI ecosystem that, as I said earlier, would allow you to easily embed AI into your applications and transparently benefit from the AI acceleration that we provide on our Z16 and Linux One servers. We wanted to make sure that we make it just as easy for you to consume AI, not only in Java and Python and Go applications, but also in your existing COBOL and even assembler applications. And I'll show you some examples of that later on. And the third key focus areas around AI for us was AI agility. We wanted to make sure that we give you the freedom of choice and flexibility to be able to train and develop your models in any platform, any framework. We heard from a lot of you that you had made great investments in training platforms, whether those were on our Z servers or on the cloud or on distributed. And we wanted your data scientists to have the freedom to develop their models on the platform and framework that they desired, but then being able to very easily take those models and data science assets and deploy them on Z. So we invested in technologies such as Onyx and our deep learning compiler. And Onyx is an open standard and format for representing AI models. So we can take a model in the Onyx format and compile it and generate a Z-optimized executable that would leverage our AI accelerator on our Z systems. Now, I wanted to give you a little deeper view in terms of the AI ecosystem that we've built. So not only, as you can see from the bottom of the chart here, we made significant investments in the AI hardware accelerator that we provided in Z16 and our Linux One servers, but we've made even more significant investments on the software stack side. So we provide these capabilities on our Linux environment as well as our ZOS environments. We'll optimize a lot of the libraries that are very popular with the big data and AI community, such as OpenBLAST. We support the 4 popular languages of AI, Python and Go, and Java and Scala, and our Linux systems are as well. And if you go up to the 4th row from the bottom here, you've seen that we've brought a lot of the AI frameworks and tooling from the open source to Z. And not only have we brought those AI frameworks and tooling to our Z platform, but we have instrumented them and optimized them for a Z architecture such that you can automatically and transparently benefit from all the acceleration and optimizations that we have made in the underpinning layers of the stack. And just to give you a quick example here, TensorFlow, we have TensorFlow container images. TensorFlow is one of the most popular AI and frameworks that our clients are using to create, develop, and deploy their models. So we have an optimized TensorFlow container image that you can deploy in your environments that when running on a Z16 server will automatically leverage the AI accelerator. And from an AI application user perspective, from a data science perspective, you can develop and deploy your models in TensorFlow on Z without any changes, the same way you do in any other platform, and then being able to benefit from the AI acceleration on our servers transparently and seamlessly. And higher up in the stack here, you can see that we have our own product offerings in the AI apps space that, as I said earlier, help you monitor and tune your applications for performance, as well as help you monitor your systems and proactively detect anomalies and help you map those anomalies to problem signatures to enhance the resiliency of your systems. And at the very top, you see AI frameworks and tooling that we provide to help you with the whole end-to-end AI lifecycle with products such as Cloud Pak for Data, that is a unified AI platform, and also Watson Machine Learning on the z/OS side as well. Very quickly, I wanted to highlight, as I said earlier, that not only have we optimized our own product offerings to leverage the AI acceleration on z16, but we have instrumented and optimized open source AI frameworks such as TensorFlow, and you can deploy TensorFlow in our Linux environments, but as well as in ZCX and z/OS container extension environments on the z/OS side. So this gives you the capability and gives your teams the capability to actually leverage AI by deploying your models in TensorFlow or TensorFlow serving in ZCX or in our Linux environments, and then being able to invoke those models from an application to get a prediction or recognize new patterns through REST API endpoints. Very quickly here, as I said earlier, it was very, very important to us that we offer you AI agility and flexibility. So for models that are developed on other platforms or frameworks, you can still really, based on the tooling that we provide, have those models optimized for our Z platform and deploy those models on our Z platform. So you can see on the left-hand side here, a plethora of AI frameworks and models, and all of those support the ONNX format. In PyTorch, for example, you can export a model in the ONNX format and save your model that was developed in PyTorch in ONNX. On Z systems, we'll take that ONNX model, compiler it through our deep learning compiler that would generate a Z-optimized executable inference program that then can be called from any application to make a prediction. So again, this provides a lot of flexibility and really gives you the ability and the freedom to be able to develop and create your models anywhere and then have them deployed on our platform, but also have them optimized for our platform. And we have integrated our deep learning compiler into our Watson Machine Learning for z/OS product offering, and makes it very, very easy to do this compilation on Z systems. The IBM deep learning compiler is also integrated in Cloud Pak for Data for our Linux environments. Now, very quickly, I wanted to spend a little bit of time on the AI hardware accelerator itself. This is a very unique accelerator. It's the industry first AI accelerator for enterprises. What you'll see here is our AI accelerator sits on the same silicon as the cores, and that makes it unique in that it shares the level 2 cache as well as memory with the cores. So we get the benefit of not incurring the overhead of having to move the input parameters to the model and the model itself from main memory to a device-specific memory, as is the case of GPU-like accelerators. So not only are we accelerating some of the very complex math functions that are part of computing and inference or scoring and transaction, for example, but the fact that we have direct access to the data, and we don't have to move that data to the accelerator gives us the benefit of having an accelerator that's optimized for very low latency. So it gives you the best response time, but it also gives you the throughput and the scale you need to actually examine every transaction in real time. There's really some key innovative technologies that went into this accelerator, such as automatically converting the input to our own deep deep learning float format that actually reduces the memory footprint and speeds up computations while preserving the accuracy of these algorithms. But I think one of the greatest things about this accelerator is that we built an ecosystem on top of it that really abstracts a lot of the nuances of the hardware architecture from an application user perspective. And because we have made all the optimizations in the underpinning layers of the stack, when you run, let's say, and deploy models in TensorFlow, as I said, or in Watson Machine Learning for ZOS, you don't have to worry about really knowing anything about the accelerator, because both the open source tooling frameworks, whether you choose to leverage AI through open source AI frameworks or through our own product offerings, they have been optimized and instrumented to leverage this accelerator. If you're running in one of our servers like Z16 or the Linux One Emperor 4 server where this accelerator is available. And a couple more comments that I'll make here is this accelerator comes with your servers, is enabled when you buy a Z16 or a Linux One Emperor 4 server. And from a software perspective, a lot of the software and the AI ecosystem I talk about on the ZOS side, they run on zips. Obviously, on the Linux side, they run on IFLs. So I tell clients, the accelerator comes with your box. It's enabled from a software cost perspective, right? It's not going to impact your MLC charges on the ZOS side. So really, if you're not utilizing these capabilities, you underutilizing all that your server can provide you. Very quickly here, just to give you a benchmark that we've run, this is a credit card fraud model, and it's a model that very closely reflects a lot of the models that a lot of banking clients are using and credit card clients are using to detect fraud for credit card transactions. We worked and collaborated with a lot of them to get a lot of the characteristics that are part of doing credit card fraud detection. And you can see here as we scale the machine up from 1 chip to 2 chips to 8 chips to 32 chips, we can go up to serving 3.5 million inferences per second at 1 millisecond latency, which is enough for most of our clients, not only to meet their today's needs, but actually anticipate your future growth here. One other thing that we focused on, especially on the ZOS side, was to make sure that even CICS and COBOL applications can very easily leverage state-of-the-art AI without having, as I said earlier, to refactor your applications. So what you see here in this example is Watson Machine Learning, which is our own product offering, where we took the Watson technology and tailored it for ZOS environment so that it makes it very, very easy even for CICS COBOL applications to leverage AI. So when you see in the black boxes here is many of you may recognize this CICS commands, this put container channel commands pass input parameters to the model. Then they link to a program called ALN score provided by Watson Machine Learning for ZOS to invoke the model and then get the prediction back. So again, with just a few lines of code, even in COBOL applications, our clients can leverage state-of-the-art AI to make predictions or recognize new patterns. I also wanted to really make you aware of a key capability that we added to DB213. We added this SQL Data Insights, as we call it, which is a key feature of DB213 and comes as part of DB213. And this capability enables you to issue semantic queries, that is, SQL queries that don't match on the exact values of the data in your DB2 tables, as is the case today, but where you can use simple constructs to get the semantic meaning of that data and really discover hidden relationships between the transactions, between your transactions and the data that you already have in your DB2 databases on z/OS. This is really a very innovative capability, and I'll show you an example of that in this next chart. This is the telco example, and what you see here is customer with customer ID 1 has just left this telephone company, this telco company, to go to a competitor. And this is a customer churn example. And this telco company wanted to find out what other other clients had similar characteristics as this customer with customer ID number 1 that may have the same propensity to leave this telco company and go to a competitor. So they can, with this DB2 SQL Data Insights capability that we have in DB2.13, they can issue a SQL query that you can see here that says, what other clients in my DB2 database are similar to customer ID 1 and therefore may have the same propensity to leave our services and go somewhere else? So what you get back is a ranked list of clients based on similarity score that, again, may also have the same propensity to go somewhere else and look at competitive offerings. And what you see here in green is actually the columns of the features that contributed most to the similarity score. And this telco company can use this information to actually offer incentive offerings for these other clients that they have and customers that they have to stay with them. And this is a customer churn example, but actually you can leverage the SQL Data Insights for many, many different use cases, for cross-sell and upsell use cases, for anti-money laundering use cases, and so forth. So a very key and exciting capability, leveraging state-of-the-art neural network AI technology in DB2.13. Now, I wanted to talk a very high level in terms of the offerings that we have, AI offerings on our Z systems. In the top row here are IBM offerings that enable our clients to manage the whole end-to-end AI lifecycle and analyze their data for insights, as well as leverage and deploy AI models in your production workloads. And at the bottom is examples of how we're leveraging AI in our own product offerings to deliver additional client value. Open Data Analytics for z/OS is actually the foundation product offering on the z/OS side for analytics. We have our own distribution of Apache Spark, and Apache Spark is a very popular in-memory analytics framework. We also have a lot of the popular Python packages that are used for machine learning and deep learning in this offering, as well as our own virtualization layer that lets our customers leverage all of their Z data, whether it's system log data or SMF data or vSUM data, and it provides a virtualization so that this data can be leveraged through, let's say, Apache Spark SQL queries and through methods and APIs that are available in these AI frameworks and tooling. And then Watson Machine Learning for z/OS, we took the Watson technology and tailored for z/OS environments so that it makes it very easy for our clients to deploy AI within their existing applications without having to do major refactoring of those applications. And I showed you an example earlier. Cloud Pak for Data is a unified AI platform that allows our clients to actually discover and access and govern and analyze their data, no matter where that data resides or that format of that data. And really is our premier offering for AI on our Linux environments. Our clients really are able to create and develop and train their models in Cloud Pak for Data, as well as deploy them. And we have optimized Cloud Pak for Data to leverage a lot of the acceleration that we're providing on our Z servers. I talked about DB2 for ZOS with SQL Data Insights, around, again, how we leverage state-of-the-art AI in DB2.13 to help you derive new insights from your DB2 data while you're using existing SQL constructs. And at the bottom here, you see offerings such as DB2 AI for ZOS, where we actually train our model based on your unique operating environments to help you tune DB2 applications for performance. For example, one of the capabilities it provides is it helps you determine the best performing query access path for dynamic queries for DB2 applications. And then IBM Z Anomaly Analytics, or IZAA, where it really helps with detecting anomalies, alerting you of anomalies, mapping those anomalies to problem signatures so you can more quickly be able to get to problem resolution, as well as reduce your mean time to recovery. And then Watson AI apps, and we really have integrated IBM Z Anomaly Analytics with Watson AI apps. Watson AI apps is a unified platform for being able to observe and monitor your IT systems, inclusive of your Z systems, because we integrated IZAA with Watson AI apps. And then finally, the DB2 Analytics Accelerator that has been available for a long time now, that really enables our clients to be able to accelerate some very complex SQL queries and really process HTAP queries. Now, let me spend some time on use cases, because I talked about technologies and product offerings, and really, to me, when the value comes in is around how our clients can leverage these technologies and how these technologies translate to client value and business value for your businesses. We all know that AI is applicable across a wide set of use cases, across many, many different industries. And you can see here from banking to finance to trading to insurance and many, many others. But what I wanted to cover and spend some time with you today is really the AI use cases that we work with clients on, and the benefits that those clients see from leveraging AI on our platform. And I'm going to start with the fraud detection use case for a credit card authorization application. We worked with one of our big banking clients, and what they wanted to do was to augment the credit card authorization process with machine learning. Today, they used to determine whether a credit card transaction is fraudulent or not based on static business rules, and they wanted to enhance that process with machine learning so they can improve the accuracy of their predictions. Now, this particular client tried to do this originally off platform. So from ZOS, call out to a server on distributed to score those transactions. But they very quickly found out that that architecture was not working for them. They were getting frequent timeouts, inconsistent response times. Even when they would get the prediction back, it would be upwards of 80 milliseconds, as well as having to let many transactions complete without the benefit of AI. In addition, they told us that it could only score about 1,200 transactions per second, which was a little less than 10% of their transactions, but they had the desire to have the ability to score 100% of their transactions. So in this particular case, we helped them bring this model that they had developed off platform and deploy it on Z close to this credit card authorization runtime. And this particular client was able now to score within 1 millisecond latency 100% of the transactions, which was 15,000 in this case. And as a result of that, they told us that they saved over $20 million in fraud prevention savings annually. So this was an online in-transaction real-time use case. The next use case is a clearing and settlement use case. And this is a use case that we worked on with Visa. On the back end, Visa has a batch workload in this case, where they settle their credit card transactions, and they told us they wanted to apply AI to this batch workload, but without elongating the batch window. And they said, by the way, the number of online transactions has dramatically increased during the pandemic, and we'll continue to see, the number of transactions we have to settle increase, but we want to make sure that we can apply AI to this batch workload and not elongate a batch window. So in this case, we help them deploy this model in TensorFlow and ZCX in this particular case. And again, they were able to achieve the SLAs that they needed. The next use case is a loan approval use case where we help the Canadian bank automate the loan approval process and to be able to very quickly approve or reject loan applicants and actually come up with scoring that indicated that this applicant was credit worthy or not. The fourth use case is a claims fraud use case where we work with a state agency in the US, a governmental state agency, to automate their claims processing. And what they wanted to do was to actually make sure that their auditors could focus on claims that were flagged as potentially fraudulent versus having to sift through every claim. So they leverage Watson machine learning on ZOS in this case, so they can have their auditors, as I said earlier, do deep dives on claims that were flagged as fraudulent, rather than having to look at every claim. And this really saved them, many hours of task work that these auditors had to do, and let them focus on claims really that were most likely fraudulent. This next set of use cases, again, it's fraud detection in payments. We worked with a European bank that leveraged, again, Watson machine learning on ZOS to be able to introduce in the operation flow machine learning to detect whether a payment was fraudulent or not. The next use case is instant payments. Again, we worked with a European bank that was doing anti-money laundering screening once a day during the night to day post-processing, but they told us that they could see new legislation being drafted that would require them to perform AML screening on every instant payment, and they wanted to be ready. So they wanted to do AML on all of those payments in real time. And again, we help them do that on ZOS. The next example is an insurance underwriting example where AI is being leveraged to help insurance underwriters actually come up with the right set of premiums to better attract customers, but also help them assess the risk of potential clients that were in areas, let's say, of risk areas where they might have floods, or areas where they might have wildfires, for example. And the next example was with Dataport. Dataport is an IT services company that provides IT services for a lot of the German governmental agencies. And they worked with us in this particular use case to scan aerial drone images for tax assessment purposes. So for example, if somebody had a pool that wasn't declared, then they would get a new and improved tax bill. Now, I wanted to take a little bit of time and talk a little more about use cases in the healthcare industry. But you can see here, we've been working with state agencies and governmental agencies, not only in the US, but in other countries as well, where we can help them leverage AI to detect medical fraud. Also, leverage AI to auto adjudicate a lot of the claims that are coming in, and you can see the benefits that health insurance companies or governmental agencies who administer health plans can achieve through improving their auto adjudication rate even by 1 or 2%. Here, as you can see, it will result in millions of savings. And then working with clients around 360-degree of their members, right? The healthcare members, their patients, for example, and being able to proactively recommend either health plans or medications to make sure that these health insurance members actually, especially if they have a chronic disease, that they can manage the progression of the disease or offer them care to make sure that those patients receive the best outcome as possible. In the last few minutes that I have with you, I want to do two things. One is actually show you a high-level reference architecture of some of those clients, of how they actually, what they used and what components of our AI ecosystem they used to implement those use cases. And you can see here they do have choices. But let me actually show you that with the actual use cases. If we look at this fraud detection use case for the credit card authorization application that I talked about earlier, you can see that this client used for their credit card applications, they were in a KICS application environment, and they leveraged Watson machine learning for ZOS, where they actually deployed the model, and Watson machine learning for ZOS was set up for you the scoring engine, right, the inference program, and also set up an REST API endpoint that the application then can call. This particular client, because they were so happy with the credit card results, they also wanted to leverage AI in the debit card environment as well, and that was in an IMS environment. And again, they leveraged Watson machine learning for ZOS to use the REST API to invoke these AI models to get predictions as to whether these debit card transactions were fraudulent or not. And then with Visa on this clearing and settlement side, what they've done is they had this clearing and settlement batch workload running on ZOS. They stood up a ZOS container extension environment where they had TensorFlow serving to serve those models, and then they used a REST API endpoint again from the clearing and settlement application to pass the current transactional input parameters to the model. But what they also did was in a Redis in-memory data cache, what they had was the last 90-day aggregate data of each credit card account holders last 90 days of transactions, which they also passed as input to the model so they can get improve the accuracy of their results. So you can see here how you can leverage open source. Visa told us they wanted to leverage TensorFlow serving because they wanted to be consistent with the way they deploy AI models on other platforms for other applications, even in the ZOS environment. And they leverage ZOS container extensions to deploy their open source TensorFlow serving environment where it would serve as a server of those AI models. And you can see how they did that here. I want to go over one more use case if we have the time here. And this is the example of the anti-money laundering. And in this case, for this client, it was a COBOL application that you can see here. Not only do you have a REST API option of invoking an AI model with Watson machine learning for ZOS, but you can directly call it from a KICS COBOL application environment through linking, right? Doing a KICS exec link command and directly calling a program that will invoke the inference model and give you the predictions back. And with that, really what I wanted you to be aware of is that we offer an AI on IBM Systems and Linux One Discovery Workshop that is provided by our IBM Client Engineering for Systems team that really can take you through all the way from use case inception for an AI use case that is valuable for you and your business, all the way to a POC implementation of that use case. And it's available on no charge, so you can get some hands-on experience about all these AI capabilities that I talked about today. And then at the end of this deck, I have even additional material of places that you can go to get more information about AI on Z. We have our AI on IBM Z and Linux One Technology 101 page where you have the link here. We also have a content solution page that gives you a lot of useful information. And then we have an IBM container registry where you can actually, where we actually provide highly curated container images of a lot of the AI open source and frameworks that you see here, and many, many more that you can leverage in your systems. And lastly, again, a lot more information. There's links here, and they don't show best against this black background, but we have demos. We have the credit card fraud model that I talked about is available here, as well as the synthetic data set that we use to train those models, demos, red books, white papers, so a wealth of information that you can leverage. And feel free to reach out to us. It's been a pleasure really spending the time with you talking about AI on Z, and feel free to reach out to us if you have any questions. And with that, I'm going to turn it over to Michael.
Awesome. Thank you, Elpida. This was really some fantastic content. I just wanted to say that every time we talk about AI and Z or anything on Z, I'm always amazed at really the capabilities that IBM has integrated into this innovation, into that core capability of having a really reliable, stable, available system that's really run people's businesses for decades. And so that innovation is just, it's fantastic. It's fantastic to see. As Elpida mentioned, these workshops around AI and Z are things that you clearly can reach out to IBM. You can also reach out to us here at Evolving Solutions. Reach out to Scott at Evolving Sol, who's our main Z series contact. He will be more than happy to get involved in helping look at AI on Z. We're working with a number of clients right now on this. So looking forward to working with anyone who's interested. And thank you again, Elpida. Appreciate your time. And thank you everyone for joining us today.